Hello everyone. I Dr. Vinay Kumar, Mechanical Engineering Department, Associate Professor in TGPCET, Tulsi Ramji Gaikwad Patil College, Nagpur. Today I am going to teach you about material engineering. So, why do we study material science? To understand how materials are made. There are different processes to make the materials we will study in the further videos. To know how material behave under load and environmental condition. It is very important when we make some kind of material, we have to consider various aspects like load, environmental effect, so that we can enhance the life of the material, also for the parts. To know the effect of mixing and how mixing changes the material power, it is very important. Then there are different material properties like strength, hardness, ductility, brittleness, malleable. We will discuss in the next PPTs. To know about the structure of the material, how it looks like, because structure of the material looks like a microstructure. We can examine microstructure either by microscope or we can use the scanning electron microscope, XRD machine, different machines so that we can understand what is the difference between the steel, cast iron, brass, and phosphorus bronze material. To select a material for different engineering applications. Of course, we can see that in reality, we can wear the certain band. It is a different material. We cannot make it by using the steel because otherwise it becomes very difficult to wear because in sun in during the afternoon it becomes very hot and it is not useful for us and we can so there are different engineering applications for the different materials, so we cannot also make our pen by steel. It becomes very heavy, and also we cannot make that steel or cast iron for the shoes. It becomes also very heavy, and also it becomes very costly. So as we are the engineers, so we need to think where we can apply, where we can use that material for the best approach to optimize the overall cost of the product. That is very important. It is very important so that otherwise the company will not get the profit on it. For research, it is very important. What is the market survey? It is very important. What is the need of which material, which parts is required in the market, which is very important to become multidisciplinary engineers. So that it means you must become multidisciplinary engineer. It means you must go with the different engineering like artificial intelligence. You can also use some kind of CAD. You can also use some sensors so that you can enhance all those things. The next topic is this history of material origins. So I add over here so you can just take a simple example how the history changed. Some prehistory, stone eggs, gold, silver, iron, cement, leather, rubbers, etc. These are the history. So here is just one slide. You can go through it, and I'm going for the another slide. So you can see it's engineering material. There are different applications. You will see the one tower, one gear that is also in the homemade applications, sensors, etc. So engineering material refers to the group of materials that are used in the construction of man-made structure and component. The primary function of an engineered material is to withstand applied loading without breaking and without exhibiting excessive deflection. So these are the common applications, and these are that is the engineering material. It means when we apply force, it should not be break easily, depending on the application. And the classification of material, there are different kind of materials. First is metals. In metals, there are ferrous, non-ferrous, non-metal, and composite. Ferrous metal is steel, alloy, steel, stainless steel. Non-metals, cement, ceramics, graphite, plastic, elastomers, composite, carbon, resin, fiberglass, resins. Mechanical properties of materials. There are list. You will see that strength, elasticity, plasticity, hardness, toughness, brittleness, stiffness, ductility, malleability, cohesion, impact strength, fatigue, cream. You will also go with the YouTube videos for the reference. Strength. Strength is a mechanical properties that enable a material to resist deformation load. It means if you apply some kind of force on a wall, it should not be deformed. That is what strength. Strength of material is capability to withstand destruction under the action of external load. So there are a different kind of uh, definitions. You will see the stronger the material, the greater the load it can withstand. Elasticity, we will see here. One example is very easy. That is a elastic rubber. When we apply a force on it, then its shape and size will be changed. But when we release that force, it come in the original position. That is what elasticity. That is what elasticity. According to the dictionary, elasticity is the ability of a object or material to resume its normal shape after being stretched or compressed. When a material load is applied to it, it causes, but it can come to the original position. That is what elasticity. The elasticity of a material add to its power of coming back to original position after deformation when the stress or load is released. So these are the various definitions for the elasticity, but the simple thing is that when you use rubber band, apply force, so the size and shape will be changed. But when we release the load, it becomes in the original position. That is what elasticity. Example: heat treated springs, rubber, etc. are the good example for elastic material. Plasticity, if you'll see that there is a pen, we applied a force, the shape and size change, but when we released the force, it cannot come to the original position. So the some kind of deformation will be takes place. So the plastic of material to its ability under some permanent deformation without rupture. Plastic deformation will take place any after the elastic range has been exceeded. Pieces of evidence plastic action in structure material are called yield, plastic, and creep. There are different kind of materials such as clay. If you see clay, lead are the plastic at room temperature and steel plastics when at bright red heat. So the plastic is a very simple example I explained, that is a pen. If we apply a force, okay, so it can change, but it cannot come to the original position. That is what plastic. Hardness, if we understand the hardness, if a one material cannot scratch, penetrate, or bending resistance will be there, that is what hardness. So the hardest material in the earth, that is diamond, which is already appear in the slides. The resistance of material to a force penetration or bending is hardness. We will see one example. Use your finger and try to apply on the wall. You will see that your finger is going to be scratched on the wall paint, so that it means the wall paint is not hard. If we are going to compare here, so that the hardness is the ability of the material to resist scratching, abrasion, cutting, or penetration. Hardness indicates the degree of hardness of a material that can be imparted, particularly steel by process. The next slide. So hardness, it means what? Which can resist resistance of the material, so that there will be no bending, no penetration, no wear will be occurred. Toughness, the toughness is what it withstand shock or impact. It we will consider the application like manganese steel, wrought iron, mild steel, etc. are the toughness materials. We will see toughness. We can also consider the windshield of the cast iron. So toughness also having a very different application. Also windshields, we can take a windshields application of the car is tough when the car is accident with something, the glass or windshield, it is not going to break directly, because there is a force which is gradually distributed, so that the person who is sitting on the car, it is not going to be harmed. So we can use toughness in also which brittleness. This is one of the example. If you'll see, there is a one chocolate which is we apply force, that is break, it will break, that is called brittleness. Brittleness of the property of the material which is it withstand permanent deformation. Cast iron, glass are example of the brittle material. They will break rather than bend under shock or impact. So when we apply more force, it suddenly break. Generally, the brittle metal have high compressive strength but low in tensile. So these are the two photos I had. One of the KitKat and the another one is the cast iron grill. When we apply force, it breaks. directly. Stiffness is it is a mechanical property. Stiffness we will see stiffness is a resistance of a material to elastic deformation or deflection. Stiffness which suffer light deformation under the load, but it can come to the original position when we relieve the forces. The stiffness of a structure is an important in many engineering applications, so the modulus of elasticity is often one of the primary properties when selecting a material. So on the right side, we will see one spring is there when we add on force or load so that it stretched up to delta, that is what deformation or deflection, that is stiffness. Ductility is what when you will see one copper metal, it is going to be changed in the copper wire. It is what ductility. Ductility is what material which enable it to be drawn out into thread wire. It means when we melted copper metals by adding or some other alloys so that we can get copper wire. Mild steel, copper, aluminium are the good example for the ductile material. Malleability, you will see in the diagram where we hit some materials on it and so that we can get some kind of coins on it. That is what malleability. The malleability we will see past 20 years back, 10 years back, we have a one kind of a bucket, steel bucket we can use in our daily basis at your home. That is what we can have a steel plate, we can hammer it, and then we can make it a one steel bucket. The malleability is the property of a material which permits it to be hammered or rolled into sheets or other sizes or shapes. Aluminium, copper leads example of this. We will have the so many example of it. Now, steel bucket we used before 5 to 10 years. That is a simple example of it. Cohesion, it is a mechanical property. The cohesion is a property of a solid body by virtue of which they resist from being broken into a fragment. Impact strength, when we apply a force, it resists suddenly applied loads. The impact strength is the ability of a material to resist suddenly applied load. It cannot deform. Fatigue, so here we can see that due to fatigue, fatigue is what? Fatigue is a long effect of repeated straining action which cause the strain or break of the material. It is a term fatigue used to describe the fatigue of material under repeatedly applied forces. So the if I'll give a very simple example of it, so we will see one just took a one wire and then you can just loading and unloading, just take a wire and try to load, unload, load, unload, so you will see that there is a repeated load on it, and then after some times you will see that the wire becomes in a two parts. That is what fatigue. Creep is a slow and progressive deformation of a material with time at a constant force. The simplest type of a creep deformation is viscous flow. It goes slowly, slowly, slowly. Or you will see a some materials are generally exhibit creep at higher temperature, whereas plastic, rubber, similar amorphous materials are very temperature sensitive. The force for a specific rate of strain at constant temperature is called creep. So creep, we will see also one example that is a belt. If some guys the weight is suddenly increases, so you will so the in belt will say that there is a slow and a progressive deformation, but it required some time so that it can become break. That is a simple. If we see a belt, that is a simple example of creep. Thank you very much.